part 2 in solving second law of thermodynamics under thermodynamics and heat transfer. For our part 2 problem, we have here the air enters an automotive supercharger at 100 kilopascal. It is under a temperature of 300 Kelvin and is compressed to 150 kilopascal. The efficiency is 70%. What is the required work input per kilogram of air? And what is the exit temperature? So, our given is listed on our extreme left corner. And for this, we are going to use this formula. Lowercase letter W sub S is equivalent to the constant pressure na given multiply to the difference ng temperature estimated and temperature initial. So before using that formula, we still need to find for our estimated temperature since it is unknown for us. So this is the formula to be used. So plugging in all the needed values in this formula, we have the 300 Kelvin, the initial temperature, our estimated pressure 150 kilopascal, and initial pressure to be 100 kilopascal. For our compression ratio, we are going to use the constant, which is 1.4 minus 1 over 1.4. We now have the temperature estimated to be 336.8 Kelvin. So after getting the temperature estimated, we can now proceed to answer the question, the required work input per kilogram in our automotive supercharger under a pressure of 100 kilopascal and 300 Kelvin initial temperature. So plugging in all the needed values in our formula, we have here the constant given, that is 1.004. This is under constant pressure multiplied to the difference or initial and estimated temperature. We now have the work input per kilogram for our automotive supercharger to be negative 36.9472 kilojoules per kilogram. It is just the work input, but we did not still answer the question, what is the required work input per kilogram? So that is just a part of our given and the next formula. This is now for acquiring the required work input per kilogram for our material. So our WS to be negative 36.9472 kilojoules per kilogram all over 0.70, that is the efficiency of our supercharger. So after that, calculating this, we have negative 53.0 kilojoules per kilogram. So this is now the required and needed work input per kilogram for our automotive supercharger. Let's proceed to our next question. What is the exit temperature of our automotive supercharger? So we have here TE stands for the temperature exit is equivalent to the initial temperature, that is 300 Kelvin, minus the negative 53, the work, all over a constant, that is 1.004. So we now have the exit temperature to be 352.8 Kelvin. This is the exit temperature of our automotive supercharger under a compressive pressure of 150 kilopascal and an efficiency of 70%. So that's it for our part 2 problem under second law of thermodynamics. Thank you so much for listening, everyone, and see you on our next and upcoming videos to come.